Imagine you're building a machine learning model for a high-stakes decision. For example, predicting whether someone will reoffend. Every prediction this model makes changes a real person's life. For a decision this consequential, you don't want a black box explained after the fact. You want a model that's explainable by design. So you reach for a decision tree. Specifically, the standard CART tree, which is the default in scikit-learn. You train it on real recidivism data, and overall, it looks pretty good, about 68% accuracy. But zoom into one leaf, and something troubling shows up. It splits young defendants with 2 priors based on race, where Caucasians are predicted not to reoffend. On training data, its accuracy is 52%, barely better than a coin flip. On data it hasn't seen, it drops even further, just 45%. That's not a fluke you can write off. That leaf hands out a local explanation that race decides the outcome, while barely being backed by any data at all. A classification resting on evidence that weak isn't just imprecise, it's misleading, and it's something we should avoid. Usually, decision trees are optimized for plain accuracy. That can let a leaf be wildly inaccurate on very little data, since it barely moves the overall number. Instead, we propose leaf accuracy. Measure the accuracy inside each leaf separately and take the minimum across all leaves. That's the number we maximize. When the tree is trained this way, the worst leaf stops being close to a coin flip. Its test accuracy jumps from 45% to 62%. This does not come entirely free. The overall model accuracy dips by about 1 percentage point. But you can win most of that back by extending each leaf with a more capable model like XGBoost, trained just on that leaf's data. Across the benchmark, the proposed model suffers a drop in model accuracy, but extending the leaves negates this difference to CART and even closes much of the gap with tuned XGBoost. What about cost complexity pruning, or an optimal tree approach like OCT by Bertsemers and Dunn? CART shown here is already pruned, and its leaf accuracy trails ours by about 7.5 points. OCT scores even worse, more than 11 points behind, because neither of them considers leaf accuracy. That suggests that overall accuracy is not a good proxy for leaf accuracy. This is a piece of a bigger point. If you're using a decision tree as an explanation, its least reliable leaf matters as much as its overall score. Check out more details in the paper linked below.